is Node.js exactly? Node.js is a server-side JavaScript runtime environment. Let's break that sentence down. Node.js is a server-side. It's an application that runs on a computer's operating system, as opposed to in a web browser or on a phone. JavaScript runtime environment. It's an application that looks at JavaScript, decides which JavaScript files or commands should be executed and when, and then sends that JavaScript to an embedded JavaScript engine, V8, for execution on the computer. If you recall what the V8 is from the previous lecture, you can think of V8 as a car's engine and drivetrain, while Node.js is everything else that makes the car, the seats, the steering wheel, the windows, etc. And as a Node.js developer, you are the driver of the car. If you didn't have Node.js, it'd be like trying to drive an engine down the street. You'd have to manually squirt gas into the cylinders at the right time and pull on pieces of the chassis to make it turn. It'd be very difficult to drive the vehicle down the street. And without the engine and only the car's shell, you wouldn't be able to go anywhere at all. So both the engine and the shell are important and crucial to being able to operate the car. Similarly, without Node, using V8 would be very difficult. You'd not only have to write your JavaScript files, but then write another application that packages up and send those JavaScript files to V8 at the right time, then handles the response. Node.js does all that for you. So what is Node? It's a C++ application that embeds V8. If we look at the first few commits that Ryan Dahl made to Node.js, we can see him embedding the V8 application and then writing more C++ that handles the logic of figuring out which JavaScript to send to V8 and when and what to do with the responses. In modern Node.js, you can still see V8 embedded in there, though the rest of the code base is many thousand times larger than it used to be. In crafting Node.js and iterating on it over time, Ryan Dahl and other contributors have made two primary programs, both of which get called from the command line: a REPL, read eval print loop, and a script processor. Let's start with the script processor. The script processor gets called by simply invoking node and naming the script you'd like to execute. Example would be node index.js. In this way, you're passing a script name to Node.js so that Node can open that file and process the JavaScript commands within it. But it's a bit more complicated than that. When you invoke the Node program in this way, Node isn't simply going to pass your JavaScript to V8. It's first going to initialize a process called the event loop, and then it's going to process the initial parts of your JavaScript file, and then it's going to start processing the event loop it initialized earlier. You can think of the event loop as an infinitely repeating task that starts over just as soon as it completes. Each pass of this task, or each tick as it's called, consists of Node.js checking to see if there's anything else it needs to do. Now you might be saying, wait, didn't Node already process the file at the beginning before it started the loop? Well, yes and no. If you recall, JavaScript can include both synchronous and asynchronous behaviors. Synchronous behaviors are executed and completed by Node as soon as they are encountered, while asynchronous behaviors are simply invoked but not immediately completed. Instead, these behaviors just get added to a queue, which lists everything asynchronous that Node.js still has left to do. The event loop is Node's way of processing that to-do list. With each tick of the loop, it completes an item or several items on its list, but those items may very well create further items, asynchronous operations that need to be completed later. So every time the event loop runs, the number of items left to complete may just stay the same, or it may grow. If at some point the event loop checks off the final thing it had to do on its to-do list and there's nothing left for it to do, the application exits. That's the end. If, however, each task on the list creates a new task on the list, and so the length of the to-do list never reaches 0, then it's possible for Node to run indefinitely or infinitely and never reach a point where it needs to exit. Many Node programs like servers or background workers, for example, are designed this way to perpetually create more items on the to-do list and never let their to-do list get down to 0. That way, the application never dies. Items that can be added to the to-do list include any tasks that shouldn't be executed synchronously, such as those invoked with a callback, and those whose execution is scheduled at a later time, such as timeouts and intervals. We call this umbrella of tasks non-blocking. In many programming languages, everything you do is blocking. That is, if you have a sequence of tasks that need to be performed, your single-threaded application will perform each task in order, and while it's executing each task, it is incapable of doing anything else. That is what is meant by blocking. Each task is quote-unquote blocking if it is occupying the resources of the thread and if the application logic will need to be focused on that task at the expense of anything else it might be doing at the time. Blocking tasks and runtimes with a blocking I/O definitely have their place if you must perform a sequence of tasks in an exact order and there is nothing else your thread would rather be doing, then there is virtually no drawback to a blocking I/O. But that is often not the case with modern web applications. Web apps often need to handle and process multiple things at a single time. While your API is fetching database results for one user's request, it must also be simultaneously sending a welcome email to another user and looking up the Twitter profile of another while charging the credit card of yet another. So, how does a non-blocking I/O enable an application thread to handle multiple things at the same time? Well, it doesn't. Node.js is single-threaded, although it can spawn other threads, which we'll discuss later. But for argument's sake, it's best to understand Node as having a single thread that can only do one thing at a time. The concept of a non-blocking I/O and the concept of an event loop doesn't allow Node to do multiple things at one time. It just allows Node to schedule things later. This might sound trivial, but it's actually a huge deal. If you take a close look at what modern web applications actually do when they process a request, the vast majority of the time, they aren't actually doing anything. They're just waiting for some other thing to do something. And while they're waiting, they are blocked from doing anything else. For example, let's say you've created an API in a language or platform that only has a single-threaded or blocking I/O and doesn't allow any asynchronous calls. Now let's say a post request comes into the API, and that request contains the information of a new user, and that user data needs to be written to the database. Your API parses the request, gets the user data, then sends the data to the DB, waits for the DB to respond. While your code is waiting for the database to respond, it is blocked. It's not doing anything. But since the platform has a blocking I/O, it can't do anything else. There might be many other things that your API could be doing and wants to do at that moment, accept and respond to different requests coming in from another user, or perform some background task, but it can't. Not until the database responds, and much of your backend system likely acts this way. It contacts other services via RESTful APIs and waits for them to respond. Or it writes information to the database, it performs reads and writes to the disk. While it's doing these things and waiting for its counterparty to respond, it is blocked from doing anything else and it's stuck in a state of idleness. Non-blocking I/Os and event loops are the answer to this issue. You see, when Node is faced with processing the same API request, it will take in the user data, parse it synchronously, just like any other API, but then when it needs to send that information to the database, it will send off the information to the DB, then put an item on its to-do list saying, whenever the database responds, process the response. So now, while the database is processing the data, the Node.js thread will move on to its other tasks, process other user requests, etc. When the database finally responds, the event loop processor will see, oh, I just got a response from the database and I have a to-do list item saying to send that response to this function over here. So I'm going to do that now. In this way, Node.js is continually getting out of its own way. When it encounters anything that would normally require blocking the thread and waiting around doing nothing, Node is designed to move that task out of the way and then do it at some point when it has downtime. Node is simply much better at managing its own time. It's constantly reprioritizing the tasks in front of it, so it's never sitting around waiting at a time when it could actually be doing something. Many of the Node APIs, such as writing to disk, are designed asynchronously in this way, and as a Node.js developer, you're encouraged to design your programs around this idea as well. So now you understand how Node executes the tasks inside of a JavaScript file. It works with V8 to decide which function should be executed and at what moment and in which order. It interacts with third-party counterparties like the disk or databases and APIs, but never sits around waiting for them to respond. Instead, it keeps itself busy with other tasks while counterparties are taking their time to respond. The idea of non-blocking I/O, asynchronous functions, and the event loop all revolve around this concept. Now that we understand that, we need to get a handle on how Node runs an entire application split across many files. After all, when you start a Node application, you don't specify a set of files or a directory of files. You actually only specify a single file that needs to be executed. This may seem counterintuitive because, as you know, applications are often made of dozens or hundreds or thousands of individual files, not just one. So how does Node start an entire application when all you tell it is to start one file? This is where Node's module system comes into play. If you've used Node before, you've likely encountered require or import statements like these, usually at the top of source files. Here's an example. Within Node, require and import, which are ES5 and ES6 syntax respectively, do virtually the same thing. They grab a resource from elsewhere and allow you to assign the contents of that resource to a variable or define it as a constant. Similarly, if you've looked at a Node package or module before, you've likely seen that it contains a module.exports or a export declaration. This line declares what content should be sent to another file when that file imports or requires this one. For example, file A is an object containing a function called foo. File B wants to use file A's foo function, so it imports or requires all of file A and assigns its content to a variable called myImportedFunctions. Now, file A's foo function will be available to use within file B by calling myImportedFunctions.foo. As you browse through a Node.js application, you'll see import or require statements all over the place. These are Node's way of letting each file say which other file's contents it needs access to. When you zoom out, all of these require or import statements form a bit of a tree. The index.js file requires the controller file. The controller file requires the lib file. The lib file requires the SDK of some database, and that SDK requires several helpers, etc., etc., etc. So, back to the topic at hand. When you start a Node.js application by invoking a single file, Node simply starts reading through that file, looks at which other files it requires, then reads those, looks through which files they require, and reads in those other ones, and continues all the way through all of the files that the entire application needs until it has read the entire application into memory. So in this way, if you have an SDK or library or package sitting in your application's directory, but none of the files in your application ever call that SDK, Node will treat it like it doesn't exist, and won't read it into memory when the application starts. So let's go back to the original question we were trying to answer. What does Node script processor do? Now we can see it does a few things. When you call node index.js, you're passing the name of the index.js file to Node, and it will begin reading it, and then it will read in all the other files by traversing the dependency tree codified in those files. And then it will begin executing the synchronous tasks called in those files, and then start processing all the asynchronous tasks by repeating its event loop over and over until it has nothing to do, isn't waiting for any responses, and has nothing scheduled for the future. And at that point, it will exit. Now that you understand the script processor, understanding the REPL, or read eval print loop, should be easy. The REPL works much like the console within a web browser. It is a way to define and execute JavaScript code against the V8 engine in real time. When you enter the node command in your terminal, but don't supply a file name for Node to execute, Node will start the REPL automatically. You will see a cursor marker appear in your terminal, which tells you that the REPL has started the R phase of its process, reading input from you. So initially, all the REPL is going to do is start the event loop in the background, then sit and wait for you to write something and press return. Here, you can write any statements that you could write in a Node.js JavaScript file. The caveat is, line breaks within strings may need to be escaped with a backslash before you press return. But besides that, you can do anything you want within the REPL. You can define variables and manipulate them or add them together. You can define and execute functions, and you can even define and execute asynchronous processes. The REPL stages are just what they sound like. It moves from R, reading input from you, to E, executing whatever you wrote, to P, printing its response or the return values of your functions or whatever your code said should be logged. And then it does L. It loops back up to the top and repeats that process again. All of Node.js is made available to you within the command line, including requiring and importing modules. So that is how Node works. Now let's take a closer look at a sample Node.js application and walk you through the pieces that you see there.